Comfort Criteria. Welcome to the Comfort Criteria section in Price's training module. Everyone likes to feel comfortable and performs better under pleasurable conditions. In this section, we will define human comfort and thermal comfort, discuss the factors that contribute to comfort, calculate the level of comfort in a zone with effective draft temperature, and learn how to rate an air diffusion system with ADPI. What is comfort? Comfort can be defined as a state of satisfaction a person has with their surrounding environment. However, many factors can contribute to this, such as air temperature, air movement, relative humidity, air quality, acoustics, aesthetics, clothing, activities, emotions, and perception. Perhaps this definition is a bit too general. The purpose of an HVAC system is to maintain an environment that ensures the comfort of its occupants. So let's focus our discussion a bit more on thermal comfort. If you're interested, more information on acoustics is provided in the Noise Control Fundamentals section of the Price Training module. Thermal comfort. We now know what human comfort is. But as HVAC designers, we must understand more specifically what thermal comfort is. Thermal comfort is achieved when heat generated by the body is balanced and transferred to the surrounding space, and the occupant is not aware of this process in any fashion. What do we mean by a balanced heat transfer? A healthy person has an internal thermostat that is on average set to 98.6 degrees Fahrenheit. This temperature varies slightly between people, seasons, time of day, and what activities they are doing. In indoor environments, the body is usually warmer than its surroundings, and since heat naturally dissipates from a hotter object to a cooler one, heat travels from the body to its surroundings. This transfer of heat is in the realm of control by the HVAC system designer and is based on these three factors: surrounding air temperature, humidity, and air velocity. We'll learn more about these factors in the upcoming section. Temperature, humidity, and air velocity. Now that we know what comfort is, and the three factors that affect it, temperature, humidity, and air velocity, let's see how we can apply that knowledge to improve our environment. The American Society of Heating, Refrigerating, and Air Conditioning Engineers, also known as ASHRAE, have researched environmental conditions in which people are comfortable and have determined that neither a specific temperature nor humidity makes everyone comfortable. In other words, comfort is subjective. Any attempt to define the best temperature or humidity relies on statistics. As each person has a unique perspective on what constitutes thermal comfort, ASHRAE recommends that the HVAC designer aim for 80% occupant satisfaction. After extensive testing, ASHRAE has found that at least 80% of the population is comfortable if the air temperature ranges from 77 degrees Fahrenheit in the summer to 72 degrees Fahrenheit in the winter. The humidity ratio. This refers to the ratio of the mass of the water vapor to the mass of dry air contained in a sample. ASHRAE Standard 55-2004, Thermal Environmental Conditions for Human Occupancy, has established that a humidity ratio less than 0.012 will provide the best level of human comfort. For example, if your room temperature is 75 degrees Fahrenheit, a relative humidity level of 63% would be ideal. The comfort level also depends upon airflow within the room. When selecting grills, registers, or diffusers for a particular application, this is perhaps our greatest concern. Research shows that for the typical office space, a comfortable airflow varies between 30 and 70 feet per minute. At higher velocities, airflow will be perceived as a distraction. While air leaving the face of our diffuser will surely be a higher velocity, airflow should not exceed 50 feet per minute in an occupied zone. By using the proper air diffusion devices, this air movement can be easily controlled. In conventional mixing ventilation systems, we make sure to avoid thermal stratification and stagnation and that the room air is a homogeneous mixture. Stratification occurs when air in a room divides itself based on temperature. The hotter air rises while cooler air falls. An acceptable temperature difference from head to ankle for standing occupants is 5 degrees Fahrenheit. For seated occupants, the difference should not exceed 3.6 degrees Fahrenheit. Those are a lot of interacting conditions to keep track of at once. The following section will show you how the information we've learned so far can be grouped and simplified. Effective draft temperature. To better interpret the information we've just discussed, HVAC designers have combined the effects of temperature and air movement into a single number. This number is called the effective draft temperature. It's a numerical value that offers an indication of comfort within a specific space. The effective draft temperature can be calculated as follows. Where T equals the local temperature in degrees Fahrenheit, Tc equals the control or ambient temperature in degrees Fahrenheit, and V equals the local velocity in feet per minute. Research indicates that a high percentage of people are comfortable where the effective draft temperature difference is between -3 degrees Fahrenheit to +2 degrees Fahrenheit, and the air velocity is less than 70 feet per minute. This chart shows the relationship between temperature differential and air velocity in the occupied zone. Any combination of temperature and velocity which falls outside the shaded area would be perceived as a draft. Note that the temperature values given are the difference between the local air temperature and the ambient air temperature in the occupied zone. For instance, in a room with an ambient temperature of 72 degrees Fahrenheit, we could encounter 69-degree air in the occupied zone at 30 feet per minute, and it would not be perceived as a draft. However, were we to encounter 67-degree air in the occupied zone at 30 feet per minute, it would surely cause a sensation of draft and result in discomfort. Next, we'll see how this process can be taken a step further by learning how to measure the effective draft temperature in an entire room. ADPI. Now that we understand what draft temperature is, here's how it can be used in determining the comfort level in any room. Equipment can be set up to measure temperatures and velocities at uniformly distributed points in a room. If at each point the draft temperature is within the -3 degrees Fahrenheit to the +2 degrees Fahrenheit range, and the local velocity is less than 70 feet per minute, then that point meets the comfort criteria. After checking all of these points, an Air Diffusion Performance Index, or ADPI, can be determined. This ADPI value has proven to be a valid single number rating of an air diffusion system. This is a calculation of the number of points that meet the comfort criteria divided by the total number of points, times 100. An ADPI of 80 means that 80% of the points measured have air temperatures and velocities within an acceptable range. An ADPI of 80 or above is considered adequate to meet the comfort criteria according to ASHRAE Standard 62-1989. The ADPI rating of an air diffusion system depends on a number of factors: outlet type, room dimensions and diffuser layout, room load, and the outlet throw. When these factors are properly selected and managed, most applications should be able to achieve an acceptable ADPI rating. Conclusion. We hope that you've enjoyed this look at comfort criteria. You should now have a better understanding of human and thermal comfort, which refers to a balanced heat transfer between people and their surroundings. This heat transfer can be affected by temperature, velocity, and humidity. We've also learned how to measure the comfort level in a zone and seen that ASHRAE recommends that 80% of the population is satisfied with temperatures between 72 to 77 degrees Fahrenheit, a humidity ratio of 0.012 or less, and air velocity below 50 feet per minute in an occupied zone. We've looked at how to calculate the effective draft temperature, which is a numerical value indicating the level of comfort at a point in space. We've seen how all of the points in a room can be combined to determine the Air Diffusion Performance Index, or ADPI, of the entire room. To learn more about thermal comfort and ventilation, you can refer to ASHRAE Standard 55 for thermal comfort and ASHRAE Standard 113 for room air diffusion. In addition to that, you can also refer to the price catalog or visit our website at www.price-hvac.com.